Hi everyone, we're going to have a quick look at how to use non-monic trinomial factorization for expressions or functions where a times the factors of a times c can add to b. So let's go through some definitions and then we'll give it a go. So a monic trinomial has an x squared term with a coefficient of 1. This is an example of a monic trinomial. The coefficient of x squared here is 1. We don't write 1, but there's a 1 there nonetheless. A non-monic trinomial factorization, a non-monic trinomial function has an a value that does not equal 1 and also does not equal 0. If it equaled 0, it'd be a linear function or something else. But it can't also equal 1, because if it equaled 1, it would be a monic trinomial. So here's a non-monic here where a is equal to 2. If we defined our trinomial in the terms of y equals ax squared plus bx plus c, the standard form for a quadratic. Now, if we want to factorize it, as in put it into two brackets, we could use non-monic trinomial factorization, where a times c, the a value, times the c value, we can find factors of it that add to b. If we can't, we have to use the quadratic formula. There are some methods that also use methods similar to completing the square, but we're not going to look at those right now. We'll look at those as a part of turning point form. So let's assume that a times c, there's a factor of a times c that can add to b. If that happens, we need to follow 4 steps. Firstly, split the middle term, the x term, into factors of a times c that add to b. Then factorize the first terms and the second terms. Factorize again, and then factorize any coefficients of x. So there's 4 steps. They don't sound like much when they're put like this, but when we do the problem, it makes a little bit more sense. So let's start with y equals 2x squared plus 7x plus 5, and we want to put it into two brackets into factored form. So we look at a, we look at c, and we multiply them together. And in this case, I've used a little t-chart to record it. 2 times 5 is 10. I wrote it at the top here. And down here, I wrote the factors of 10, specifically looking for factors of 10 that add to our b term 7, and I wrote 7 at the top here just to remind myself. Factors of 10 that add to 7 are 5 and 2. 5 times 2 gives me 10. 5 plus 2 gives me 7. To make trinomial factorization work, I have a look at the first term. I have a look at these two numbers and I think, well, which combination of these two numbers is going to factorize easily? In this case, I have a 2 here, so using the 2 makes sense. And what I want to do is I want to split this term into 5x and 2x. Here's the 2x, here's the 5x. 5x plus 2x still equals 7x. This equation here, this expression here, is still equal to this expression here. So, writing it out, I've now got 2x squared plus 2x plus 5x plus 5. I've split the middle term, or the x term. Then, I'm going to factorize the first two terms, and I'm going to factorize the second two terms, and something quite miraculous will occur. So the highest common factor here is 2x. I stick that out the front. 2x times x will give me 2x squared. 2x times 1 will give me 2x. I have a new term. Then I factorize the second two terms. Factorize out 5, and I get left with x plus 1. And looking at my solution here, I've now got an x plus 1 common to each bracket. To get this, or to regroup this, I'm going to factorize out the x plus 1, and that will give me a 2x plus 5. Now if I multiply this out, I get back to this. 2x times x plus 1 is this expression. 5 times x plus 1 is this expression. I now have it factorized, but to get it into factored form, I'd really like it to be an x here and an x here without coefficients, or with a coefficient of 1, I should say. So to do that, I'm going to divide both terms in this bracket by 2. If I divide this by 2, I get left with x. If I divide this by 2, I get 5 on 2, and I'm going to put the 2 out the front. Now I have an expression in traditional factored form. Now from this factored form I can tell a few things. One, that a is greater than 0, so the function is going to be concave up and have a minimum, and the x-intercepts are going to be at negative 5 on 2 and negative 1. I could have got a similar answer from this by using null factor law, but it's half a step and you have the x-intercepts up straight away. Let's try another example. Here's example 2. It's a similar expression, except now I've got a negative sign here, and we'll see how that changes things. A times c will give me negative 10. I've written that up here. I've got 9x in the middle. I'm looking for factors of negative 10 that add to 9. That would be 10 and negative 1. 10 times negative 1 is negative 10. 10 take 1 is 9. Looking at these, I'll want to use the negative 1 this time. So splitting the middle term 9 into negative 1 and 10. 10 take 1 is still 9. Then I'm going to factorize this. The highest common factor is x, which will leave me with x times 2x will give me 2x squared. X times negative 1 will give me negative x. And then do the same for the second pair. The highest common factor is 5. Put that out the front. 5 times 2x gives me 10x. 5 times negative 1 gives me 5. And lo and behold, I can regroup again. So 2x take 1, bracket x plus 5. I haven't got x as my lone coefficient, my lone variable in each bracket, so I'm going to divide this bracket through by 2, which I've done here. 2 times x gives me 2x. 2 times negative a half gives me 1. I just divided negative 1 by 2. Now I know that it's concave up, and I know that the x-intercepts are at half 0 and negative 5, 0. Second problem done. Third one. Now we have a negative a term. That's still okay, same method. Negative 2 times 5 gives me negative 10 still. This time I'm trying to make 3. 5 times negative 2 gives me 10. 5 take 2 gives me 3. Since I've got negative 2x squared out the front, I'm going to use negative 2x here, this negative 2 here, because it'll be easier to factorize. And put 5x here, which is the second of my factors that I identified through this little process. Now, factorizing the first two terms, highest common factor is negative 2x. Negative 2x times x gives me negative 2x squared. Negative 2x times 1 gives me negative 2x. Factorizing these, highest common factor is 5. 5 times x gives me 5x. 5 times 1 gives me 5. I can regroup by taking out x plus 1. There it is there. Negative 2x is here, 5 is there, that times that gives me this, that times that gives me this. Divide through this bracket by negative 2, gives me x. 5 divided by negative 2 is negative 5 on 2, which leaves me with an a value of negative 2, indicating that the function is concave down, and we'll have a maximum. The x-intercepts are at 5 over 2, 0 and negative 1, 0. And that's how we do non-monic trinomial factorization. It's well worth having a go. The steps aren't particularly onerous, and you don't want to make it out to be something more difficult than it actually is. If your normal monic trinomial factorization is good, the one extra step won't be a big deal for you. So I can give us a little cheer. And finish up. Thanks, everybody.